I would like to give now the word to Ben Proesmans of Provan. Ben Proesmans is the owner of Provan, and Provan is a metalworking company in the province of Limburg in Henk, who has invested heavily in quick response manufacturing as a production philosophy, but also in the necessary IT tools to support this. And Ben will share with us his journey he has undertaken.
So welcome everybody. My name is Ben Proesmans from the company Provan, and I'm going to try to share some of the experience of what we did with QRM in our company, and also some of the IT tools that we are using to improve our way of working in our company. So let me first introduce you who we are as Provan. We are a tailor-made metal solution, so we are a subcontractor in metalworks, and we're trying to do several works for other companies in metal. Okay, so tailor-made solutions. We are doing everything in the sheet metal work, like I said, and okay, we're trying to be an innovative supplier. That's one of the things that we're able to, and in the metalworking, like I said already before, we are looking for a long-term relationship with our customers and our partners as suppliers also, and we're looking for companies who do their production or outsourcing their production. And we do it all this by QRM, quick response manufacturing, and if we do it in quick response manufacturing, we try to look for our customers and our partners the total cost of ownership. That's one of the most important things what we are trying to achieve with our partners and our clients. One of the things over there is our core business, and our core business is profile machining, sheet metal work, welding, and assembly. And we can do that in steel, aluminium, and stainless steel. So sheet metal working, you can see some pictures over here from the sheet metal working laser cutting, and also folding and bending. On the other side, we also do profile machining by tube laser also. You can see the machine over here. And at last, I'll say we do welding, robot welding, and manual welding, and that in MIG, MAG, TIG. And we have also a separate unit for stainless steel welding. And if the client wants, we can also have a department for assembly where we can produce or assemble all the products completely ready to be packed and sent to the clients, or to the clients of our clients. So in all this, we're trying to do by quick response manufacturing. QRM is the guideline in our company. And why we're doing that is one of these effects is that sales and production often have discussion about delivery time and the lead time to produce some things. So probably some of you will recognize this kind of discussions also in your company. And we started by Provan with QRM, and why? Because we saw at one moment that consumers and customers are more and more demanding than before. So they ask for bigger variations, they ask for smaller series, they ask for suppliers to be more flexible and to get shorter delivery times. So if you look at all of that, that is quite some issue that we have to solve. And if I look from before 2012, we were producing one batch of, let me say, oranges, or we were producing one batch of apples. But now our customer is not asking a batch, but he is asking for a slide of orange, a slide of green apple, a slide of orange again, and a slide of red apple. And that is what he's asking for. He wants to be delivered this kind of product, and not the batch in big amounts like before. So we have to adapt as a supplier and as a company to receive. And I try to rethink the way of our production the way that we produce. So therefore, I started internally a work group from several people who were discussing about how to apply or how to reduce the lead time in our company. And we had a lot of discussions. Like over 6 months, we had several discussions going on in our company. And at least at one point, we did a tryout with one project. And I want to share this project with you. So here you can see one of the stoves that we are making and one of the examples where we started the way of QRM producing. So at that moment, our client was demanding or was ordering one model of stoves, and one model of stoves was 130 different parts, which should be delivered separately or as a weld assembly. And the delivery should be made at 15 sets. All these parts or articles should be stacked on, let me say, like 18 different pallets according to the specifications of our clients. And all the orders that we received from our clients was for the coming 5 weeks. This was our starting point. So at that moment, we thought, okay, how should we produce this? So we looked at the cost factor, and then we said, okay, we're gonna do a batch production by combining 60 sets at once, or at the same time. So you are very efficient in the setup cost, and very efficient in logistics, etc. But the lead time for 60 batches, it was, let's say, 1 week of laser cutting, it was 1.5 weeks of bending, and it was 1 week of welding. And if the products, these 130 different parts were finished, they were stocked in the warehouse, in racks, waiting to be picked at the time that we should deliver to the customer. And if you should deliver it to the customer, there's 1 day of picking of the products. So the total lead time for these products, when we start from producing until that they are ready to be shipped, it is 3.5 to 4 weeks. Here you can see one picture of the pallets with all the different parts in the racks. So everything went very well. Our customer was also very satisfied about our way of working and our production and the quality. And at that moment he said, okay, I want to add 2 more models to you as the supplier or our partner. So this means, okay, for me in sales, it was, yes, okay, yes, great that we have 2 more models so that our turnover will grow. But on the other hand, in production, there was some issues. And the problem was there, we should have additional stock space for the process step and the shipping of all the products. We didn't have enough available space at that moment to be 2 new models. We have to increase our stocks. And our customer was asking, or his request was, instead of 5 weeks of forecast, we only have 3 weeks. And one other point was the product changes. If there were product changes, and there were a lot of product changes in this kind of work, you'll only be able to produce these after 200 sets, because in the first week you make like 60 sets. In the second week, like I said, you make another 60 sets, and third week 60 sets. And after 4 weeks, you have the first ready. That means in the work in process, there will be like 200 to 240 sets ongoing in work in process. So if you want to make some changes, you can only do this after these 240 sets, or you have to scrap parts or do a rework on them. So that was a lot of products ongoing. So one of the other problems was the long lead time of the finished products, because the mix of 3 models. Like I said, the lead time was 3.5 to 4 weeks. And if I have 3 models that I have to make, that means that I have to have stock of each model, and I don't know what or which part or which model they will sell. So I have to increase my my stock to be able to deliver on time to our customer. Also, one of the points is that the first kit of 15 sets can only be shipped after completes all parts already. So if there are still some parts to be welded, you can only ship when the last part is ready to be complete sets to the customer. And also another point was, if there are some changes in delivery times and in models, it is very difficult to accommodate and to manage all these changes. So at that point, there was only one option. If we want to succeed and we want to be able to deliver this to our customer, we have to change our way of working and change our way of thinking. So at that moment, there was a breakthrough after all these discussions that we had internally with the work group, that we're going to create one cell completely dedicated to this kind of products. And therefore, we create a cell. We moved also machinery to this cell that we need for this production. We're going to produce in 15 sets instead of the 60 sets, so we're going to reduce the quantity of the delivery, and we're going to only produce what is ordered by our customer. Also, the cell operators control the workflow in the cell. That means the operators are now on charge of the workflow in the cell. Also, because now we're looking at the total model instead of each part separately, means that we have less production orders to monitor than we had before to monitor. That means a lot of administration that is gone. And we are using visual ads to provide a clear overview of the situation. So these are the things that we did. And you can see here a picture with on the side all the machinery, and here in the middle you see all the racks that we have with all the products on it, ongoing in production. And to make this overview clear, we added, like I said, already some colors to the process steps. And one of the things was for treating, it was yellow, rolling, it was green, bending, blue, and finally also packing and shipping, it was gray. And I want to show you now also one of the steps that we did. So we started here at the first one with to separate the products from the laser cutter. You have all the picture of which rack or which pallet, what products should be on the pallet. It was going on. Then also, if they have on this pallet, there should be a treating. It was yellow, like I said. Also rolling, it was green. Blue, it is bending. And so you can see over here one of the flags that we had on this pallet. That means this is pallet number 15, where we have a blue flag that means bending. We have a green flag, it is rolling. We have the yellow flag that means that it's treating, and the gray flag, it is control. So that means all the flow and what should be done, it is actually here you can see color flags and the different or multiple pallets over here. Also, you can see over here one green card, and this is actually for our robot welding. So all these parts are already bended or rolled, and these parts are going to the robots to be welded at that time. So finally, you have also here the inspection. Only the gray flag is there. What I can mention also for this flag maybe, if the work is done on the pallet, you take out the flag out of the car. So you start with several colors, but afterwards you only will be left only the gray flag. That is final control and packaging, and after packaging, all flags are done. So that means if you look at that, the results that we have from this work is that the workflow is now completely self-steering. So it is easy to understand thanks to the color codes. So if you're able to work 1/2 day in this cell, you understand the way of working, and there are no more explanations needed. We don't have any detailed planning anymore. There's very or almost none production steering needed at the moment. Only when to start and when to has the product to be ready. That's everything that has to be monitored in the cell. All the rest is done by the people in the cell on its own. And one of the most important things what is going on is the lead time of these 15 sets. It was before 3.5 to 4 weeks, and it's now reduced to 3 days. So that means it's a big advantage, a big change in the lead time for this production. Also, one other thing is the packaging. Before it was 1 day, and now it is reduced by a half day. So that means we still have to package, and we still have to do this. But that means, okay, it's like 50% reducing of the time. And also here before, this is almost 85% reducing of the lead time in the company. One other thing is also adjustment or changes can now happen on the next production run, because we don't have any stock or any components on stock. So if we produce everything that is ordered, we can make these changes directly by the next production without scrapping or without rework in the company. And reduction of the stock in place, you saw before the racks, we don't have them anymore, and that means that we now have more than 600 square meter of production or stock in place, or stock available for production instead of stock. Also, the orders of the client are now at 3 weeks. That means also for us that we are able to do that in 3 weeks without getting any stock. So still it is very good. And also our client can react better and faster on a sale request, because the delivery time for him and the stock also for him for different models is now reduced also, and he can do it on a faster way because he can react simpler on the requests of the clients, of our clients. We also improved our quality because our workers are more and highly involved in complete production in the cell. So also here we have an improved quality result for our customer. So this is a good result of one of the cells that we built on QRM. On the other hand, like I said, we are a subcontractor in metalworks. That means that's not only this stoves that we make a lot of more products, a lot of different products. But the way this is working in this cell, we would like to improve this also in the rest of our company. And therefore we looked for a digital tool that we are trying to find how to manage and to use this in the rest of our company. And we came there with a system called Provan. You can see it over here on the screens, that we are trying to organize our system and the flow in our organization. It's quite important. And one of the things is, if you look at the traditional production, you have one operator and one machine. One operator and a machine, here again, one operator and a machine, and products are going from the one operator or one machine to the other machine. So if you're going to draw these lines, you can draw a lot more lines in this. That means there's a big spaghetti that is going on to have the product going through the company. And also when you have this kind of organization where you have a lot of moving points from products, it is very difficult to manage because the communication has to follow this way of working. And that means that people should know what they have to do and how they have to do it. And in this kind of production way like this, where there's a lot of spaghetti, let's call it like this, there has to be a lot of communication. On the other hand, when we're looking at our way of working, we reduce this kind of production to this kind of production. So that means we are using some cells where there are different machines and some different workers who are working together in this complete cell. And in this cell, these people are cross-trained for the different machines. That means the capacity is not on the machine or on the worker, but this shared capacity in this cell. And also, if you're moving like different cells in your company, you can see over here that you are able to reduce the lines of communication between these cells. And if the workers are cross-trained in the cell, they also can manage in the cell or organize the work in the cell on their own. So that means that they are able to be involved much bigger than in a normal way of working. Also, the screens that we're using by each cell, you can see one of the pictures over here. There's a lot of information on it that can be shared from management also to the worker on the floor. So that means if you look at the screen over here, you can see over here that these first orders are the orders who are in the cell. Also here are the orders who are already at the cell. They can start it over there. And these are the orders who will come to the cell but are not arrived yet over there. Also, you can see what capacity, you can see the capacity over here for everybody. And also what's very important in this automatic, let me say automatic planning system is that the most urgent order is always on top. It is like in the on the airport, the flight who is going the first or to leave the first, it is on top. Also here it is the same. And every 15 minutes we have an update of our planning. So if there's changing something, one order is already ready in the cell before, or there's a material who's coming into the warehouse, the flow or the order who is on top can change every 15 minutes without talking to anybody, without letting anybody know if there is some changes over there. So that means there is always the most urgent order on top. Also over here you can see one picture. If you have one cell, one screen with each cell, and then you have the communication between these cells. You can see over here the order is going in over here, and so they are communicating with each other, all these cells, without that any person, any team leader or something, or any body who needs to make the planning, he has to be involved here. It is done completely automatically. So what are results of this software is that it is much more easy to make the planning because we don't have a planner anymore. Also, the flow in the organization it's steering the flow in the production, so it's quite easy to manage and to understand. Workers are more involved in the total flow because they're seeing and they have also the same information as the management as everybody. So, like I said, okay, and the bottlenecks are coming. So there's a lot of information shared by the management and our workers on the floor. So one of the next things that we did also is one of the partners that we are doing also business with in the IT is Azimuta. And that's work instructions. So here we make our work instructions. So we manage our work instructions for the products that we're making. We have our people who are using them, these work instructions, for the benefit of the making the product. We train our people. We can do the audits in our cells and in our departments, and also we can improve our way of producing and follow up this whole system in Azimuta. And one of the things, for example, is in our assembly, we have like this iPads or this screens we're using, and therefore yes, the work instruction is here visible and clear on what they should do. And also we can add here pictures and get more information clearly visible for our workers to know what they should do or not should do. Also, we can put in checks if we want to be sure that they are doing some of the handlings. We can ask for checks, and they have to commit that they did that, or make a picture, or scan a serial number, or something like that. It's it is possible to do that on the screens here. So, and automatically also, if we do that, it is online. That means we can also see the status of each product on any time. So, and one of the things also there is we have here a control report. And like I said, okay, if I ask my people to confirm if they did some of the steps, they can do it. And afterwards, I can generate here a report of a control document that is able to, for each product, that they did or did not okay with that step. Also, one of the other things is we're doing in this system also, we are following up an update of a product or a change of products. We fill it in the system and we follow up every step that we should do in this changed product or complaint. And we can see all time, you can see how far we are or who is responsible for the next step in the follow-up of this product or this product change. Also from products and from all the specifications that we are doing or in the assembly of the products, we can follow up the time and the time that is worked on the products. And we can have an overview and go deeper and deeper in this overview and make also some conclusions about different products. Are they on time or not on time in production? And from there on, you can also change or corrigate these products or these issues. And also, if you have an overview about all the products that are going on and how far they are already with these products and who is working on which product. So you have a lot of information you can share and you can see from this kind. It is easy to use, and it's also the next step. We are now fully going into this kind of system to help actually our workers on the floor, to give them the right information on the right time, and as simple as possible, that they can do the products from first time right. Voila. Also, to finish, we have the award of Factory of the Future. So we are very proud about that. We won it the first time in 2015. This is an award that is there for 3 years. The first time we won it, it was mainly because of QRM, Quick Response Manufacturing. In 2018, we did win it again. But there was the main reason there was still QRM, but also the digitalization that we are improving our way of working. Also, we won the Invoca, the Innovation Award in 2016. These are all kind of innovation awards, I think, that we are named the Factory of the Future. That's a little bit what I want to share with the people. So if there are questions, please let me know.
Yeah, Ben, I have received a couple of questions through the question and answer mode. So I'm going to pause you the questions on, and then you can answer. And there are a couple of questions on how many people can you have in a cell and what determines the number of people in a cell?
That's actually difficult to say. You can have a cell with actually maybe one guy. If you have a cell, you create. Sometimes you can create a cell because the machine is very important in your production. So you have the machine who is actually a cell, and you have like 2 or 3 workers depending on the shifts that you're working. Then another cell can be with 6 to 12 people in one cell. So it depends on which product or on how you manage your cells in your company. But the best thing should be that you have a cell who are several workers, because then they can build on a team and they build together on ideas and how to improve themselves. If you're alone, then it's quite difficult to have a team or a team inspiration.
Yeah. Another question that popped up related to cells was, what are the consequences of putting people in a cell for the required skills and competencies of the employees? So what's the impact of putting people in cells on training, for example? Did you have to train them additionally? How did you do that? Yes,
one of the most important things is cross-training. Like I mentioned also in my presentation, you have all these cells, and it's very important that you bring in time and, let's say, also money to do that, because training costs also money. But it's very important to do that, because then you have multiple choices or with people because you have a bigger capacity, and also people who understand different things. And one of the things, maybe I can show you this also here, one of the results that we made in the cells also here, we had workers probably from the yellow cell here who were going to work also in the orange, or in the, I don't know which color it is, red cell over here. And then one of the things that we didn't expect is that the yellow workers over here and the red one over there, they were filling out information how to improve flow from one cell to the other cell. So that means the yellow one will say, okay, if you do it like this and like this,
we've lost you for the last 20 or 30 seconds, I would say.
Okay. So what I try to explain is, if you have, in this cell you have cross-training, and in this cell you have cross-training, but you can also do cross-training from one cell to the other cell. What we also noticed from that is that people are going to explain what they can do better in the red cell with products who are coming to the yellow cell. So if you do it like this, or you put it like that or like that, it is much easier for us in the yellow cell and do the work faster and better. Also the other way around. People will see over here how they're working over there, and they can add some additional things in this cell to improve the work in that cell. So they can help each other over the cells. So it is not only, but you cannot do that in let's say in 1 month or in 1 year. So you start first with the cross-training in one cell, afterwards try to cross-train over the different cells. So you can improve the way of working between the different cells, because the workers are gonna see what is the difficulties in the other cells and help them from point of view of their own cell. So I hope this is a little bit the answer to the question.
Yeah, I think so. Another question that popped up was a question about setup times. Was that an issue for you, or how did you deal with that? Yes,
it is always an issue. Setup times, everybody's thinking about setup times that it is lost time, because setup time, it is where you're not producing actually at that moment. So if you're still thinking in the old-fashioned way, whatever the old-fashioned way may be, it is very difficult, because then you see only the cost. In your slides, what you presented in the beginning, you saw the lead time from a product, and you're focusing on the gray space. And the gray space is only a little bit. So if we're focusing only on the setup times, you will never change your way of working, because then your idea is it will cost more. But you have to think about all the rest. If you don't have any stock anymore and you can reduce your lead time and going fast from start to finish in your product, you may have a little bigger setup cost. But on the other hand, you're saving a lot of money in all the rest. And also, one of the focus things could be also in the cells and for the people is to reduce your setup cost. So rethink the way of working and reducing your setup cost. And then you can change much faster. For example, if we had a robot change before, it was between 2 hours to 3 hours to change a robot, welding robot setup. Now we're doing it in less than 1.5 hours. So we're focusing on reducing, how to reduce the setup cost, preparing that everything's going very fast, and then it is not the setup cost anymore who is pointing out the cost of the product. Yeah. Okay. Thank you, Ben, for answering these questions. There were some other questions, but we can come back to this later, and there's still some time left.